Hey folks, it's Tom with Network Engineers Playground. So I want to talk a little bit today about encrypting your files. So I have a Linux box that I keep all of my data on, and it's just I have a SAMBA share set up on there, and I share my data from my MacBook. I share data from Windows PCs. I back up my MacBook and Windows PCs to it. I keep all my YouTube raw video files out there that I edit. I keep all my compiled videos that I upload out there. I keep a copy of them. So I have about 1.6 terabytes or so, I think, of data on there now. And it's a RAID 5 of 2 terabyte disks. It's 3 2 terabyte disks and a RAID 5 that gives me 4 terabytes of storable space. So I like to back that up bi-monthly, so twice a month, and take that backup offsite. And if something was to happen while that's out of my control offsite, I want to make sure that my backups that are out there in the different locations stored offsite are encrypted so that nobody can get to them. So anyway, let's go ahead and start us a new terminal session here. I'll go ahead and use the homebrew theme. And let's go ahead and make this a little bigger. And we'll go ahead and connect, go ahead and SSH into my Linux box. And then I'll put in my password. I'm going to do everything from root here. And so now I'm SSH'd in, I've SU'd the root, and let's go ahead and get started. So I have a hard drive plugged in here. What I want to do is find that drive. So I know it's on a SATA controller, so it's going to be an SD, which is SCSI disk. So Linux puts all of its devices, per se, under a special mount point called /dev. So if you do a df-h, I can type, you'll see there is a /dev mounted right here, and that is a dev temp fs, right? And so that's a special place where Linux puts all of its devices at. So if you do an ls/dev, you'll see a whole bunch of things out here, and these are all your devices that Linux has. And you see there's all these SDs. Those are SCSI disks. So those are what I want to work with. So I'm going to do ls/dev/sd asterisk, and it's going to show me all of my disks and partitions on those disks. So SDA is my main boot disk. It's where I keep my operating system's single, I think 320 gig drive. And you see I have all my partitions here, and if you look up here you can see like here's slash, so I use SDA5. That's where my root mount point is, right? And then I have a /boot, and I don't see it in the listing there, but there's also a swap and a few other things, and my dev shim for my security stuff. So this is, I'm running CentOS 7, just so you know. This process is pretty similar for Ubuntu or any flavor of Linux. I know that I have these next 3 disks, which are SDB, SDC, and SDD. Those are my RAID 5 disks, and those are my partitions on those disks. And now here is my SDE disk. Then this is the one that I just inserted. You could uninsert it and type this command and see it go away, and then insert it again, wait a minute, type the command and see it come back. That's how you can make sure you're working with the right disk if you're not sure. I just have it in a little SATA little slide in and out tray where you can just slide the drive in and close the door, and it, it's a hot swap bay. But anyway, we know that's the disk we want to work with, and so the first thing we got to do is get it partitioned, get a partition on it. So I'm going to use parted, which is the partitioning tool of my choice. Fdisk would also work fine if you're more comfortable with Fdisk. So we're going to tell it right here that we want to work with dev/SDE. And it's going to come up. Now, if you didn't type the dev SDE, I'll go ahead and type Q to quit. And you just type parted. By default, you're going to be working with a different drive. You're going to be working with like your first one. And there's my first drive. So you don't want to delete anything on that. You can do a select/dev/SDE if you're already in it. And then it'll tell you it's using dev SDE. And you can see up here when it first loaded, there's my dev SDA 320 gigabyte. Okay, so now we're on dev SDE. Now we can do a print, and we're going to say P, or type the word print, right? We're going to print out what's the disk that's selected. And I was going to say it's got an unrecognized disk label, and the partition table is unknown. It's because it's completely blank. I bought this drive off of eBay. It came yesterday. I wrote a pass of zeros to it to wipe everything out on it. And now I'm ready to set it up. So what we're going to do first is make a label, because we have to make a label to make a partition. So that is MK for make label, right? And it's going to want to know what kind of label. So it's going to ask us what type. And you're like, I don't know what types there are, right? I know what type I'm going to make, but I'll just show you. You can do MK label help, or is it, no, it's help MK label. Right, and it's going to tell you all the different types you can make. You can even make an Amiga label, like if you have an old Amiga gaming habit, whatever. What we're going to do is make an MS-DOS label, because that's the common one, right? So we'll do make label, and you can just type MS-DOS right here. And if I spell label right, it'll work better. Now we got a label. Now if we print, like boom, there's a label. Doesn't say there's no label, so we know there's a label. And it's got a partition table now called MS-DOS. We're happy. Now we got to make a partition. So for that, it's MK for make, KRT for partition. We're going to make a primary partition. But before we do this, we need to know how much space it's seeing, I guess, right? So you can do is, we know it's actually a 2,000 gigabyte disk, but you can do a print free, right? Like boom, we see that there's start at 32K and end at 2,000 gigabytes. Size is 2,000 gigabytes, and that's free space. So what we can do is do mkpart, and it's going to be a primary because it's the first one. And I want to make this ext4. You can make it ext2 or 3. You can even make it XFS if you want that. I'm doing a do ext4. It honestly doesn't matter what type you choose here, because you're not actually going to format a file system on this guy. This is where you're going to make your crypto volume. I just like ext4. So enter. And I'll just say start at 0. Because there it goes. Okay. Oh, typed it twice. So I'm going to start at 0 because it won't override its partition table or anything weird like that. You can just say start at 0. I'm going to end at 2,000 gigabytes. And it's always going to tell you it's not properly aligned, yada, yada, yada. Just say ignore. I don't know why they even bother to do that. But we're going to do P for print again, and now we see we have a partition starting at 512 bytes and is ending at 2,000 gigabytes. That's exactly what we want, so now we can quit. My Wi-Fi is acting a little goofy. Anyway, so now we've made a partition. Now, normally this is where you would do your MKFS and make your file system. But we don't want to do that. We want to make an encrypted file system. So we're not going to have anything in that partition. It's just going to use that partition. And within it, it's going to write what appears to be random zeros and ones that nobody could interpret. And then you're going to make your file system on the encrypted file system that it creates on the encrypted partition. If that makes sense. It'll make sense once we get into it. So for that, I should have some notes open, or maybe not. Let me go ahead and just do a new window here, and I'll pull up my notes. It should be on my desktop. And oh, that's my desktop on my Mac. Okay, let me start a SSH here as well. Okay, and so right here, this backup drives.txt, I'm going to use VI here instead of nano, and just because VI doesn't have all that stuff at the bottom, and I want to make this real skinny. And so we'll kind of stretch this out. So these are just my little instructions that I have for when I get a new drive and I need to do this. So I created my partition already, so now we want to run this command right here. Alright, and this is just a command that has all of your, let's see if I can get my mouse to select everything. This just has all of your settings for the type of encryption you're going to use. So this is a real decent amount of encryption. It's all you need. There are different ciphers you can use. I like this cipher. I'm using a key size of 512. I'm using a hash SHA-512. These are all good settings. I'd recommend these settings. And we're going to use the luksFormat to make the encryption, and that's like the Linux type of encryption. I don't know exactly what all these ciphers and settings mean. I just know that these are really good settings to use. So if you want to research farther, you can just do a man space crypto or cryptsetup and go through all the settings and read what they all mean and tweak to your heart's content. So here we see I'm doing the verbose just so I can see more information as it does anything. This is the cipher I'm using. This is the key size. This is my hash type. This is my iteration time for creating that hash. And then I'm using random luksFormat. And then I'm creating it on this partition. So if I hit enter here, and it's going to say, hey, you're going to overwrite everything on this partition irrevocably. You're not going to be able to get it back. Are you sure? And you're going to say, yes, I'm sure. And you have to type it in uppercase. And now it wants you to put in the passphrase that you're going to use for this partition. And now it wants us to verify it. Pick a very long passphrase. A 8-character passphrase with the symbols and the numbers in the upper and the lower. That can take as little as 27 seconds to crack with the right video cards. And a dictionary attack if you use dictionary words. They gotta brute force it. It might take a couple days, but they'll get it. Every time you go beyond that 8 character, it comes exponentially longer. When you get out like 14, 15 characters, they're never going to get in. Right? So choose a long passphrase with no dictionary words in it. And make sure you just keep it only in your brain. So, command was successful. It's created our crypto partition volume on that partition. So the next thing we have to do is I'll come down here to my VI session. We want to mount the file system, and for that we use this command. I will put a link to these commands in a text file below the video, by the way. And what I'm going to do is do a cryptsetup open. Right, it's going to open the encryption, and the type is lux, and it's on this partition. And I'm going to name the virtual volume backup. And it's going to put that in a special place that we can then mount that to a mount point. So we'll type that command. Now we have to put in the passphrase that we just entered for the volume to open it. And it's going to cook for a second, and boom, there we go. It's mounted. So where it actually puts that is in dev/mapper, right? And then we see there's backup right there. And it says, oh, it's not a directory. Well, duh, because it's a device. So you can't directly go look at a device or change in that directory or list it. So you have to mount it. And so when you mount something, you have to first make sure there's actually a directory like off of your root file system or somewhere on your Linux system that you're going to mount it to. So right now there's nothing mounted to /backup. So if I do an ls, I'm going to see that there is this folder right here called backup. I can go into that folder and list, and there's not a darn thing in that folder, right? It's just a big old empty folder. But if I do the command to mount that, right, which is right here, it's mount /dev/mapper/backup, right? And now I'm going to mount that to that point in my file system /backup. Oh, what did I? Oh, I never made a file system on it yet. Duh. Okay. So once we get that mapped and opened, once we get it created and opened, we have to actually make a file system on it before we can mount it. So that command is going to be mkfs for make file system. I want to make an ext4 file system, and it's going to be dev. We're going to make it on dev/mapper/backup. Now it's going to go through, it's going to locate the tables, write the super blocks. It's making the file system on there so that we can actually put files on it. And so that's done. Once that file system's made, you don't ever have to type that command again. You know, once you open it, it'll be there. And so now we can go ahead and do our mount command that we were going to type. So it's mount /dev/mapper/backup, which is the device, and we're going to mount it to the backup folder. Boom. Now if I go cd/backup, there's an actual file system there, where before it was just an empty folder. It's because it's mounted. If I do df-h to see all my mount points, I will see that I have /backup mounted to dev mapper backup. It's going to say 1.8 terabytes. That's the whole, it should say 2.0 terabytes probably, but there's 1,024 bits in a byte, and the drive manufacturers go by round thousands, so 1,000 bits to a byte, but Linux actually says there's 1,024, so you always get a little less space than the drive says. That's what's going on there. That's why it looks like it's less than you think. Alright, so and so the partition's mounted, and if you want to unmount it, you can just do unmount/backup, right? So I would just come down here and say umount/backup, and I gotta get out of that directory first. It is in use because I was in the directory, and it's unmounted. I can go ahead and remount it. Boom. Okay. So what I have is some scripts that I've made. I just store them off of the root in this scripts directory. That's fine. dir will work. And so what I have here is backup.sh, firewall.sh. That's where I keep all my firewall commands. I like IP tables. Rather than dealing with the whole firewall D thing, I always uninstall that from CentOS. And then I have mount back, which mounts my backup volume, and mount back, which unmounts it. So when I run my backups, I'll go ahead and mount it first, right? So when you run a script, you always have to type a / in front of it. That unmounts it, right? And so if we look at that, I really like VI, but I've been forcing myself to use Nano lately to try to just get familiar with it better. But so, this is just my script. It unmounts the backup. And then this little command right here is what will purge any disk write caches so that you can make sure everything got written. And then it will go ahead and do a cryptsetup close, and it closes that backup under the dev /mapper/backup. It'll remove that. And then it just echoes out back to you that, hey, it's safe to remove the drive now. So that's all there is there. And so and then I have mount back, which mounts the volume. It just does the crypto setup open. And so what I do is I pass whatever drive letter it is, because sometimes if drives have gotten plugged into extra USB adapters and stuff, it might come up as SDI or SDG or whatever. So I make it so I could just pass the letter that it comes into. So normally once I got my see, I'm used to VI. Control X. Okay. Ooh, I don't want to save it. Okay. So, what I would do is do a /. You have to put the / to run a script in Linux. Mount back sh, right? And then I would put my drive letter. Now, I would tell what that is by doing an ls/dev/sd asterisk, right? And I would look at that before I put in my drive, and this SDE wouldn't be here. And then after I'd slide in my drive or plug it in, this SDE will be here, and here's that partition that we created on it. So that's how I know it's E. So now I can do /mount back, and then I'll do E. And then it's going to ask me for the passphrase for that encryption volume. And did I type it right? Yes. Okay, so now I'm ready to start my backup. If I do a df-h, you'll see /backup is mounted to dev mapper backup. That's my encrypted volume. I can write all my files there. Under my scripts folder, I actually have this backup script. I'll see. Oh, crap. Oh, don't put the / when you're editing, or the /, because that tells it it's at the root. There, okay. And that's just a couple rsync commands that are going to sync all my data and my script files over to that backup drive. Just in case I had to rebuild the server, it'd be nice to have my scripts and not have to recreate all that, right? And all my data is under /data. So all I would do now is do /backup.sh, and actually let me Control-C this. I want to actually do a screen. This is going to run for a long time, and I'm sure I'll close my terminal session, and I want to get into it later. Okay, and now I'll do screen. Basically, I can go to another terminal later on. Like if I close this, it won't abort my script. It keeps running, and if I go to another terminal session later or go to the server later, I just type screen-r. Boom, I'm right back into that script that's running. So now I'll just go ahead and start my backup and let it run. And it's just going to go through and get all my files and start copying them onto that drive. These are really big backup files that are 1.5 gigs each. So it's going to take a while, it'll be done sometime tomorrow, right? So that's how I do my encrypted backups. And once this is done running, I'll do my umount, right, script, and then I'll lock this one in the box and take it off site, and I'll pick up my other one from the other site, and I'll bring it back, and I'll do this process on it in 15 days. So hopefully that helps. You can pretty much encrypt any file system. I'll go through how to build an encrypted RAID file system. You just do this on a RAID volume. Or RAID is basically going to be the same thing, except you're going to make your partition and everything and set up your RAID. And then you can run your SAMBA shares on that encrypted volume, so that if someone grabs your server and runs away with it, that stuff's encrypted. I'll talk to y'all later. If you have any questions, post them down below. If you think you know a better way to do some of this stuff, post that down below. I will be the first to admit that while I'm pretty good with Linux, I don't even scratch the surface of knowing everything about Linux or being a Linux expert. I just have learned how to get the things done that I need to get done with Linux. And there's always a better way to skin the cat with Linux. That's why I love it. It's the operating system that just keeps on giving to network engineers. Just every time you think you know everything, you find out there's another tool in that Swiss Army knife. I'll talk to you later. Everybody, have a good day. This is Tom with Network Engineers Playground.